Here in section 7.4, we're going to look at the triangle inequality theorem. And it says that the sum of the measures of any two sides of a triangle is greater than the measure of the third side. So if we look at this triangle, we see that if we take x plus y, that has to be greater than z. Likewise, x plus z has to be greater than y. And y plus z has to be greater than x. So all three of those have to be true in order for this to be able to form a triangle. So looking at the numbers 6, 7, and 9, we want to determine if that can be triangle. So we look at, is 6 plus 7 greater than 9? Is 6 plus 9 greater than 7? And is 7 plus 9 greater than 6? So all three of those are true statements. Therefore, these lengths can be the side lengths of a triangle. Note that, well, it's kind of obvious that 6 plus 9 is greater than 7, since 9 itself is greater than 7. And likewise with 7 plus 9 greater than 6. So really, all we need to do is look at, do the two smaller numbers add up to be greater than the larger number? So we can check it with just that one thing instead of having to go through all three. So looking at the next one here, we want to know if 1, 7, and 8 can be the lengths of sides of a triangle. We look at, is 1 plus 7 greater than 8? And they are not greater than 8. Therefore, these cannot be the lengths of the sides of a triangle. Okay, try the next two here on your own. So pause the video for a moment and work those out. Okay, you should have seen that 10 plus 5 is not greater than 16. Therefore, the first one is not a triangle. And in the second, 8 plus 10 is greater than 12, so that will form a triangle. Here I've made a triangle with one side length of 8 and another of 12. And I've left it so that we can change the length of the other side, keeping those two sides constant at 8 and 12. So what is the longest that third side can possibly be if these two sides are 8 and 12? Well, if we pull this point D down to the right here, we see that Z is getting bigger and bigger, the length of segment BD. What's the largest it could possibly get? Well, since we have AB is 8 and AD is 12, we know that it can't get any longer than 8 plus 12, or 20. In fact, the computer rounds it a little bit here, so it doesn't quite show it. But can it be 20? Well, no, because if that happens, point A would be right on segment BD, and it would just form a line segment and not a triangle. So where is that number 20 coming from? Well, we see the 8 plus the 12 gives us 20. So the length of the third side must be less than 20. Likewise, if we pull D back the other way, we see that BD is getting shorter and shorter. Well, how short can it get? If I flip it all the way over down flat, then I could get to 12 minus 8 would be 4. I can't again go all the way to 4 because that would cause that to just be a line segment and not a triangle. So the length of that side must be greater than 4. So we're going to take that and put it into just a little formula. So from this we see that if two sides of a triangle are known, say we know the lengths of those sides are A and B, then the third side of the triangle is between a minus b and a plus b, assuming that a is the greater of the two. So that allows us to do example 3. What's the range of measures for a side of a triangle whose other two side measures are 4 feet and 6 feet? So if we let x be the side that we're looking for, it has to be between 6 minus 4 feet and 6 plus 4 feet. So the third side is greater than 2, but less than 14. So we're just always going to take those two known sides. On the left side, subtract them. On the right side, add them. We know the side length that we want is between those two values. Try the your turn problem. You should have found that the missing side measure is between 8 minus 3 and 8 plus 3. I suggest you always put the lower number on the left and always use your less than signs in both positions. So that would be between 5 and 11. Notice again, it can't be equal to 5 or 11, but any number between those. Try these two, and then you may begin your homework.